Oh, hello guys. My name is Engineer Haihu Hayolami. Today I'm introducing a carbon emission forecasting system to you. This system has the ability to measure the energy from the grid and convert this energy to CO2, that using energy to CO2 ratio, so as to note the CO2 emission from the grid and save this to cloud. But we have the ability to deploy this back to our systems and be able to use this to predict the future CO2 emissions. We all know that IoT helps to stores data to cloud. The data being measured by sensors, and machine learning helps us to train this data and then help us to predict the future. But whenever we train a model, we always train it with some certain set of data. But believe you me, with time, this data will become whole data and we start predicting wrong things. So we have to incorporate IoT with our AI so that this data will come straight from IoT, which has the updated data. Then I modeled the systems, modeled the power source, that is power units, using the rectification process. And then I'm having a PZEM, which is a sensor that measures current, voltage and power. And I modeled ESP32, which helped me to send all these details to the cloud. Then I'm having my results here. This is my results here. I'm having the voltage from the grid, which is RMS voltage from the grid, and then I'm having the voltage after transformer. That means the step down transformer that step it down to around 15 voltage. You can see that it goes up and down. Then I'm having the orange one. This orange one is the voltage after the capacitor, which is used for filtering. So you can see that this guy does not go down again and it goes straight. That is the function of capacitor to filter the inputs. And then I'm having here, which is the green, which is my 7809, which is the 9 volts, stable 9 volts. I'm having my 5 volts here, which is the purple line here. Believe you me, after running the model, it will actually save to my ThingSpeak data. I can see it here. The last entry was about 2 minutes ago, and you can see the effect here. So here I'm saving my voltage, current, power, and the CO2 emission, which is in kilogram. And then after this, I'm having my M file here. So here I just need to give it my channel ID and the read API keys. So after this will actually get the data from my ThingSpeak. And then after this, I use LSTM, that is long short time memory. This is an extension of Recurrent Neural Network, that is RNN. This has the ability to store information for longer period, and it is very good when you are training data that are not much enough. Then I use this to train it, and this guy has the ability to predict the CO2 emission for me. Then here I'm having the last recorded value and then the next predicted value, and then it will tell me that okay, my CO2 emission is expected to rise with time, and then tell me to try to switch it off my ID device or reducing the peak time usage. If your CO2 emission is reducing, it will actually tell you that it is reducing. And here I'm having my forecasting here. So after this, these are what it got from the ThingSpeak. These are all the data that is being stored there. And then they use this data to predict the future. Consider that this entry on April 8th, and then today is May 28th, and then that is the last data that is there. And then this guy has the ability to forecast this. So the forecasted one are the one in red. I can see it here. These are the forecasted CO2. And then okay, good. So here is it here. And the last one is this is it, which is 28th of May, and here I'm having the 30th of May. That means in 3 days time, what are the CO2 emissions that will occur? And this you can see, you can choose this from here, put it on my y as z, which is